So the first thing we're going to do here is write our first line of code, print hello world. And what this is going to do is every time you see the word print, it means display to the screen. So we're displaying hello world. So let's use Shift Enter to run this block of code or this code cell. And we see it works just fine, hello world. Another thing you'll notice is this pound and then this description of what the code does. Everything after this symbol is not going to be part of your code. It's not going to be read by the computer. Only this is. So this is just here for your sake, to remind you and other people who read your code of what you are doing. So let's move on to the next cell. Here we just have the string hello world, and a string here is one of our data structures that we'll talk about. It's just a string of characters or normal text. So what goes on here is that because we're using Jupyter Notebook, the last thing in our code cell is going to be automatically printed. Like with this print function, it'll just be done automatically. So if we run this, it says hello world, because that was the last thing in our Jupyter Notebook cell. Now let's talk about variables. So let's look at this line here. We have the string Bob is, and A is being set equal to that string. So basically A is going to be like a bucket, and it's going to hold the string Bob is. The same thing down here with numbers. B is like a bucket, and it's holding the number 25. And then we can print A, comma B, and this will print A and B with a space in between. That's what the comma means. So let's print out, and there we go. Bob is 25. Now, there's a few other things we can do. We can do math with our code in Python. So we can do 1 plus 2, and that'll be 3. It'll evaluate the 3, and that 3 will be stored in A. Then if we just type A will be the last thing in our cell, so it'll be printed out. So let's try that out. Great. Now there's some other math we can do. We can do subtraction, multiplication, division. This means taking a number to a power, so 2 to the power of 4, and then just regular addition like we've seen before. And then we can print all these things out. All of these are numbers, or in computer science we would call these integers, except this one. This is not a whole number or an integer. It's actually a floating point number, or a float. And if we're ever unsure about what data type we're working with, we can print out this function type, parentheses, of the variable, and it'll tell us what type it is. So A should be, as we defined up here, it should be a number or an integer, because that's how we defined it up here. Notice first we defined A as a string here, but then we redefined it to be a number. We overwrote A's value. Then D here should be a floating point number. Just the number 5, plain old number 5, will be an integer. True is what we call Boolean. Boolean is true or false, it's binary. And then hello is going to be a type of a string. So let's try that out. We have int, float, int, bool, and stir for string. So that all works. Now let's talk more about the Boolean values. So this is the symbol for equals 1. That is evaluated to true. So that's what will be printed as true. Notice we use 2 equal signs because 1 equal sign up here is used for assignment, we can see. So 2 equal signs is used in Python for testing whether 2 variables are equal to each other. Now this here means 1 is strictly less than 1. That'll be equal to false, because 1 isn't strictly less than 1. But this down here means less than or equal to, and 1 is less than or equal to 1. So let's test that out. Yep, we have true, false, true, just like we would expect. There are a few other things we can do. We can do true or false. Now this will evaluate to true because one of these is true. We have true and false. This evaluates to false because for and you need both of them to be true in order for it to be true. And finally we have not false. Not false is true, and not true is false, naturally. So let's run that. and it works just like we would expect. Now here's our first loop. So basically, there are going to be times when your program where you want to do the same thing or slightly similar versions of the same thing over and over again. And one thing you can use is a while loop. So this while loop is going to run while this expression evaluates to true. And as soon as it's false, it's going to stop running. So a is equal to 0 at first. As long as a is equal to 5, this will run. And so it'll print out a and increase a by 1, so then a is going to be equal to 1. A is going to be equal to itself plus 1, so it'll go up by 1. Then a is equal to 1, still less than 5. It'll print out, a will be 2, then 3, then 4. And once it hits 5, this will be false, and none of this will run. So let's test it out. Just like we would expect, a starts at 0, gets printed, goes all the way up to 4, but not 5, because once a is equal to 5, none of this gets run. Now, let's talk about lists. A list is it's a data structure that basically is a bunch of buckets to hold different values. So here we have my first list, and it's being set equal to the integers 1, 2, and 3. So we can access different numbers within this list by just doing square brackets here and the index of the number that we want. So let's try this out and just think about what might happen when we run this. So we got 2. Now you'd expect index 1 maybe to be 1, but actually index 1 is 2 because the first index is index 0. So number 1 is at index 0. Number 2 is at index 1. Number 3 is at index 2. So 1 is going to actually give us 2. I left this comment here to remind us of that. Now that we know about lists, we can talk about another type of loop, the for loop, this here. Now what this is going to do is it's going to iterate through every element of a list. It's going to, so it's for I in some list. Right now it's going through my list, which is 1, 2, 3, 4, 5, and I is going to get set to each element of this list. It's very similar to the while loop in this case. So we're going to print I and we'll see what happens. This case we have 1 through 5 because I is being set to 1 and then eventually being set to 5. So in this case we actually do get the 1 in there. Now it doesn't have to actually be a list of numbers. So let's comment this out. I'm going to use control question mark on my Windows machine, but you can do command question mark on a Mac to automatically make that whole line into a comment. And then I'll uncomment this list A, B, C, and let's run this again. Now we have A, B, C. I is being set to A, I is being set to B, and I is being set to C. So it doesn't have to be numbers. Now we can also, instead of explicitly defining a list, we can use this range function. So range is going to automatically create a list. Now range of 5 is going to go from 0 to 4. So it goes from 0 to not this number, or it excludes 5. So let's try this out. It should go from 0 to 5. And that's exactly what we see happening. From 0 to 4. Another thing we can do with loops, we can do this with while loops or for loops, we can nest them. So we put one inside the other. And so what's going to happen is I is going to be set to 0, then j is going to go from 0 to 5, then I is going to be set to 1, then j is going to go from 0 to 5, and so forth. And here we'll print out I and j, just to get a sense for what this is going to do. So here, just like we would expect, it's 0, 0, 0, 1, 0, 2, all the way up to 0, 4, and then 1, 0, 1, 1, 1, 2, all the way up to 1, 4, and so forth, all the way up to 4, 4. So there's a last thing we can do, or not a last thing, but the second to last thing we can do in this lesson is use if statements. Now this is going to control the flow of your program, essentially. So Here we're going to use Boolean values again, and a, got that. So this is going to say if a is less than b, do this. But if it's not less than b, don't do that. So either the line of code in here inside the if statement will run or not. And note for these for loops, while loops, and if statements, you're going to need to use this tab or indentation here, and Python will automatically, the Jupyter Notebook, I should say, will automatically give you that indentation, but the indentation is important. And so we have a equal to 1 and b equal to 2. We're redefining these two variables to be 1 and 2. So we have this code that should run because a is less than b, and this if statement should not run. So this line of code will never get run because b is not less than a. So let's try it out. Just like we would expect, this line is printed, but this line is not. There's another thing we can do. We can define C and D and make a more complicated if statement. So here, just like before, if C is less than D, print C is less than D. But then we have this new elif statement. That stands for else if. So if this is not true, check this next condition and see if that's true. And if that's true, print this. And then, if this isn't true, what we're going to do is drop down to this else statement. And no matter what, this else statement will run. Or, not no matter what, but if these both aren't true, this else statement will run. And it'll print the last possibility, that they're equal. So let's try this out. As we would expect, this doesn't get run, because that's not true. This doesn't get run, because this isn't true. So finally, we have this last option, which gets run. And that print statement is run, and we have C equals D. Now, here's the actual last thing we're going to do in this lesson, which is define a function. This is going to allow us to write some code and then reuse that code many times, which is really useful when making programs. It's going to dramatically reduce the amount of code you have to write. So we're going to do def for define, and then make up some name for your function. I'm going to call it add, because this function is going to add two numbers. And then we're going to pass in two variables, a and b. These you can call whatever you want. You could call it, first number, second number. And variables don't have to be one letter, even though that's what I've been using in this, though it's often better to write a more descriptive variable name. For this lesson, it's okay to use these single letters. Here we're going to do C is equal to A plus B inside of this function, and then print C. So when we run this, nothing will appear to happen, but we'll actually be defining this function so we can use it many more times. A function is almost like a person that you can teach to do a task, and then they can do it for you instead of you having to do it yourself. Or like a machine that once you build the machine, you can deploy the machine to go do some work for you instead of you having to do it yourself. So let's run this, and nothing will happen. But now we can call add with two actual numbers or pass in two variables, and it'll print 4. So it did some work, and now we told the computer how to do some work, and then we were able to tell it to actually do the work, and it did it. There's another thing we can do with functions. So let's just have this return statement. This one doesn't return anything, but this does. So instead of printing it out, it'll just return or give back to you its result, which is C in this case, the addition of these two numbers. So let's define this function. And now we can do the same thing as before, call the function name with some numbers, and because it's returning the sum of 3 and 4, it should display 7, because that's the last thing in our Jupyter Notebook cell is this function name. So it does display 7. But we can, now that we've used a return statement, we can do other things, like take what this returns and save it in a variable, and maybe use it later. So let's try that out. Yep, it works just the same as before, but now we have this a variable that's saving 5 plus 6. So that'll wrap up this lesson. I hope this was helpful, and I can't wait to see you in the next lesson. See you then.